Whoa. I'm gonna get started. Yeah, I'm gonna be talking about 3D printers. So yeah, in this talk, I'm gonna go over who I am. The focus is mostly on consumer and easy access to printers, but I'll kind of also talk a little bit about, very briefly, some other stuff. Go over the basics of slicing files, which is how you get the prints, the model, into the printer so that the printer knows what to do. I'm going to talk about how each type of printer works, um, associated costs for buying printers, some of the material costs, maybe replaceable parts that you might need, some pros and cons for each of the different types, and then a little bit of brief comparison with some other manufacturing methods, and then also talk very briefly about 3D printing services if it's like, you know, an alternative to running your own 3D printer. Yeah. More towards me. Oh yeah, does it actually like give you? Oh yeah, it makes a big difference. Apologies. Yeah, so my name is Caleb. My background is technically in software. So I spent the last decade doing full stack web stuff. Got pretty burnt out on that and have been really enjoying 3D printing and having physical things to show people. So this is kind of a variety of things that I've made. And recently I started my own business selling some of the stuff that I make. Yeah, and then, yeah, just there's a bunch of fun stuff. So I will jump right into slicing. So when 3D printing, you have a 3D model that's on the computer. Generally, all 3D printers work by laying down layer of things, and for that model to get converted to whatever it is into something compatible with the 3D printer, you do slicing. I won't go too much into the details of the specific software because that would be its own talk. There's a lot in those, but I will talk a little bit about them related to each 3D printer type. Yeah, so generally in this diagram, you can kind of see how the layers basically approximate the actual like outline of the shape, and the thinner or the shorter the layer line, the more accurate the approximation of the shape is. Different printers have different capabilities in how high each of these layers is, and I'll talk a little bit about that for the specific printers when I get into each type. Yeah. So I'm going to start with FDM printers, which are kind of a subset of generally extrusion-based printers. They just have some kind of nozzle. It pushes something out and lays that down layer by layer. FDM stands for filament deposition modeling. It's the most common term used for this type of printing, but you might also see FFF or FFM, which FFF stands for fused filament fabrication, and FFM is fused filament modeling. Yeah, this is kind of a variety. I'll talk about sort of each of these, and I'll have these pictures when I talk about each different type. For FDM, really sort of the key part of how it works is the hot end, which is what takes that plastic that you have and spits it out in each layer. It essentially acts like a big hot glue gun, or a small hot glue gun on like a CNC machine. So it's controlled by a computer to accurately place down hot plastic. And the parts of this, the number one, we have the heat sink. This is basically as the plastic is going through the hot end. You don't want it to get hot too soon, otherwise it can kind of get in a weird state where some of it's hot enough that it'll pass, but some of it'll cool down. And what ends up happening is the nozzle will get clogged because you have essentially re-solidified plastic in the hot end. So this just helps with that. And then the heat break is usually a slightly different metal that helps keep the temperature, so the hot block, the third item, can get nice and hot, melt that plastic, and then the heat break acts as like a little, usually a low conductive material like stainless steel, so that it helps keep the heat just in the one centralized location. And then we have the nozzle, which can come in various sizes. This part is sort of like Yeah, when I say it comes in different sizes, it's the size of the orifice at the very end. It helps print down. So like the most common is a 0.2 millimeter nozzle size, or sorry, 0.4. And that means that generally you're going to print layer lines of 0.4 millimeters in diameter. You'll also sometimes see 0.6. They usually just screw in, so you can just unscrew it and screw a new one in. These are a consumable. The plastic abrates them over time, and so they start to, that hole will change size and give you inconsistent prints. Yeah, inside the hot block, you also have a heater cartridge and a thermistor. The heater cartridge is what heats it up, and then the thermistor is basically just a temperature sensor, so it gives you basically a feedback loop where it's saying like, okay, we're getting hotter, we don't need to heat as much anymore, oh, we're getting cooler, we should heat back up again. And then usually there's two fans on the hot end. One is for part cooling, and then the other one is for cooling that heat sink, just to make sure that heat doesn't creep up into the nozzle and cause clogs. Yeah, the next part is the extruder. It's not shown in this diagram, but it's basically just a stepper motor that pushes plastic through into this. So it's what actually like moves the plastic through the hot end. And then also important, the surface that you print on. This can be kind of vary between things like spring steel form with a textured surface on it. That's another like type of plastic, usually PEI. You can also have glass or even like PCB material, so FR4, fiberglass, composite. But the textured build plate with the PEI spring steel is most common, I've found. Yeah, so there are kind of the most common printer for a long time that you would see is this bed slinger style, where the x-axis is the bed at the bottom, or sorry, the y-axis, and it basically just moves the whole thing forward and backwards. And then the x-axis moves separately as that tool head up in the, yeah, I forgot my pointing thing. Yeah, these ones were the most common for a really long time. They're super cheap. They are a pretty simple construction. They're easy to understand because it's basically just two components that move back and forth and have their own like axes of movement. For cons, due to the fact that it has to move the entire build surface, it means that the larger your print, the more volume and mass you're adding and having to basically move back and forth throughout the entire print. So it becomes heavier and heavier, and it's harder to move that. So there's a lot more weight, so it has to print slower so that you don't have like the print shift midway as like weird things happen with the stepper motors. Yeah, they also usually have a 4-point bed leveling, which can, if you don't do it correctly, you can actually like kind of warp the plate a little bit, as opposed to, 3 points technically describes a plane. So 3-point bed leveling is usually better. And then due to the fact that the bed moves fully forward and backwards, you basically need space around the printer to account for that movement as it actually moves outside of the like footprint of the printer itself. Yeah. The next I'll talk about is the Core XY. This one is becoming kind of the most popular type of printer now. It uses a pair of stepper motors that are synchronized to actually move the tool head together. And this one, great. Pros are that it can print significantly faster because the build plate is either stationary or only moves when you change layers. So it only has to move like a tiny amount each time, versus the whole build plate having to move on the last style. These ones usually have like good volume of like your print volume is very close to your actual printer size, as opposed to the last one with having to have space around the printer for that bed to move. This one is contained all within the footprint of the printer. The designs for a lot of these ones are easy to fully enclosed, which only really matters if you want to print like high temperature filaments that have issues with layer adhesion and other things if you print in an open printer like the last style. These ones also have the advantage that they can be compatible with multiple print heads. So you can have more than one print head on them, and the advantage of that is that you can print multiple different types of materials at the same time. A lot of times this would be used for something like printing supports in one material, and then having the other actual print itself in a different material. And the supports are just needed if you have like an overhang. You can't really print something into the air because it's just going to fall. So the supports, if you all print it in the same material, tends to bond to itself, because that's part of what the printing process is bonding the material to itself. So if you can use different materials, you get usually easier support removal, and cleanup of the print is a lot easier. The build plate, like I mentioned, is low movement, so you can have that much higher print speed since it's basically just the print head that's being moved around. There's also, they tend to have a much more rigid frame construction due to the number of points that they're like built around, which allows just more rigidity, which prevents things like print artifacts and other things that can show up on your prints. And that can be anything from like your layers shifting where somehow something happens and you end up like with the printing, like part of it is like here and then it'll shift like a millimeter and the rest of the print will be off. It helps reduce some things like that. The cons are, it has this very complicated printing mechanism where basically for it to actually move like directly in the Y, you have to move both stepper motors at the same time. So if you were to move just one stepper motor, say that lower right corner, if you were to pull, it would basically move diagonally down to the right, and vice versa. If you pull on the upper left corner, it would move up to the left, and then so to pull like to the left, you need to pull both stepper motors, basically working to pull the thing to the left, and then vice versa to the right kind of thing. So it's a little bit more complicated. It makes the construction more complicated. Yeah, and then due to the more complicated kinematics, it can be harder to diagnose the issues that show up in prints. Yeah. There is the Delta style printer. These ones are not super common, but they generally have the fastest printing speeds. They use a combined 3 stepper motors. I don't know if you saw the table that's right over there with the little robot arm. It essentially functions exactly like that robot arm, where it's using the 3 arms to basically position the tool head anywhere within the build volume. The advantage is you have the 3 stepper motors all working together, so you get the full torque of every stepper motor at any given time, and that's what helps with having the faster printing speeds. It also, due to having the 3 stepper motors all working together, it can have very high accuracy movement, so you can have very fast, high accuracy prints with a lot of prevention of weird printing artifacts. The build plate is always completely stationary on this, so it's never having to like try and move that print around like some of the other printers. And then again, similar to the last one, it has a pretty rigid frame construction, so it just helps keep everything, your prints nicer. Cons are, it's the most complicated mechanics. It has like, to build like a good print volume, the printer itself needs to be like 3 times the size of the print area. So you start to get these like really huge tall printers for like not that much more space than you would with the Core XY style. They also, due to the way that it moves, it needs to do a lot more computing. So you need a much higher computing power to do the slicing and the printing with these ones. And so that's kind of that, yeah, expensive to calculate the print head position. Yeah, this is another very uncommon printer type. It basically just acts like a record player. So it has a spinning platter and then an arm that either like moves in and out or just slides like this. You get access to everywhere on the printer. They're great for doing like vase mode prints, which is essentially a single wall spiral the whole way. Due to the circular nature, so anything that kind of just does a circle, it works really well for that. And then the disadvantage is due to having a circle, as a circle or like as a disc spins, the part in the middle is going to spin like a shorter distance than the outside for the same like degree of movement. So you end up with a weird printer, like the lower resolution that it can like move at a time for the out edge versus inner points. So you get like non-uniform print resolution. And then a con is that it's so uncommon that finding support or anything online for like, I'm having these issues, you might have a really hard time getting that solved. Yeah. And then for the FDM printers, there's a lot of really good free options that are compatible with most printers. Some 3D printers have proprietary software that you have to use, but generally for FDM, there's much more widely available options. I generally recommend starting with whatever comes with your printer or is recommended by your printer manufacturer, and then if you feel like there's something that you can't get with that one, branching out to something else. This is kind of the like general layout of most slicers. So you'll have this part is like pre-slicing. You have some settings for like which printer, types of filament, and then some general print settings. There's an easy and an advanced mode. I generally say start with the easy one. Most of the time, anything that's in the advanced settings, you don't need to change very much. So anything that you would generally change, like the layer height, you would just do in the easy settings, and that's kind of mostly what you would change. And then on the right over here is an example of a file that has been sliced. It gives you a bunch of information about like what the different lines are with different colors. Most of this you don't have to really care about. You can just see, just kind of like take a bruise through it. There's a little slider that you can see here that allows you to basically like slide up and down, kind of like scrubbing through video editing or things like that, to just see what all the layers look like. I generally only do this to look out for places that might be printing in the middle of the air, and I should have added supports or something like that for. Yeah. And then for purchase and operating costs, FDM printers are pretty cheap on the low end. Generally, a cheaper a printer is, the more work you'll have to spend on the printer versus kind of the more expensive a printer is. Usually it's just works a little bit better. That's not true in all cases, but kind of a general rule of thumb. And then, yeah, for if you really want to print other materials like ABS that don't want to stick to the build plate and want to have the layers separate, you usually want an enclosure. You can buy enclosures for printers or make your own. They're not super expensive. And then filament is usually, yeah, these are all kind of examples of some filament. They come on a big roll. They usually range from like $13 to $15 up to super ridiculous prices. Somebody was showing me today a like €950 roll of filament, but that was like for radiation, like it blocks radiation. Most of the time it's going to be like $20 for a roll of filament. I have this keyboard that I designed. It's printed in FDM. I can print about 5.5 of these with one roll of filament as kind of a price reference for how much that realistically costs. If you want to go into more engineering materials, that's when the price starts to escalate. But the average materials that you're going to use, like a PLA, are pretty cheap. And then if you live in really humid environments, some filaments are really temperamental with temperature and humidity, and they'll actually absorb water out of the air. And then they give you weird print things, like the filament will become really brittle and will just break. It'll just snap. Or you have like lots more of like little stringy things on the print and lots of weird little stuff like that. So sometimes a filament dryer is required, but generally not super needed. Yeah, and then pros and cons for FDM style printing. There is a huge range of materials, tons of colors, all sorts of options. As soon as it's done printing, you just get to take the print off and use it, which is very different from resin, where it has this whole like washing and curing and like this post-processing that you have to do. It's pretty easy to change materials because even on printers that don't have some kind of automatic filament changing, it usually only takes like a minute or two, and it's basically just like take it out and put a new one in. There are multicolor options. Some printers have a unit that allows them to print in multiple colors. You can see we have the Bamboo X1C just right over there in the 3D printing area, and that's capable of doing multiple colors. It does increase print time whenever you have multiple colors because it has to take the time to basically purge out filament. As like if you go from black to white, black really overpowers white in a color, and so you really have to purge a lot of filament to get that to be a pure white again. Some materials that you use in FDM can technically be recycled or composted. For the composted, that's PLA. It only really works in like specific types of composting facilities. Lots of people like to tout that it's compostable, but it's kind of a niche that it actually can be. But due to the fact that everything is a thermoplastic, you can technically like reheat it up and like form it into something else. So you can recycle some of your prints in other ways. Yeah. And then usually FDM has the largest build volume compared to other printer types. So if you want to print like cosplay helmets and things, FDM is going to be the way that you want to go. Yeah, cons are the calibration and tuning process can be pretty frustrating. There can be a lot of steps. The technology has advanced a lot, and people are making printers that are much better and user-friendly and work a little bit better out of the box. But again, some of the cheaper ones are going to not have some of those features. Yeah. FDM printers can destroy themselves. It's a really unfortunate thing. Sometimes, like if the hot end gets clogged, it will start to just like ooze plastic out of everything, and just, you know, it's molten, but then it cools and it just solidifies into a giant plastic block, and there's usually not really much you can do to recover that. Or like the print will fail and it just like keeps extruding filament, and you just end up coming back and it just looks like a rat's nest in the printer. Yeah. There are a lot more moving parts on FDM printers than other style printers, so they can require more maintenance over time, but it's usually not too bad. And then generally FDM prints the layer lines are larger, and so you can see the layer lines a bit more. Yeah, it should actually. Yeah. And then there are technically some other types of extrusion printers. There's this cool thing, the Cocoa Press, that actually prints in chocolate. It uses that core XY that I talked about for its printing mechanism. There's also this crazy like Mudbots cement printer that can do like, I think their max volume is like 25 by 30 feet. And so they print, you can print an entire room with that. And then there's also some clay style printers, and they all kind of work the same way, where they're just pushing something through a nozzle and putting it down layer by layer. Yeah, resin printers. So resin printers are really, really fantastic if you want fine details. They kind of all look the same with this sort of like build plate. Print gets pulled out of this resin vat. It uses UV cured resin to work. So the key parts are the build plate. You have the vat of resin, so you have basically a tub of resin. The vat itself, which contains the resin, and then at the bottom of the vat is like a very thin plastic film that's clear, and that allows the light to pass through it and cure the resin. And so this light source can be, there's SLA style printers, which stands for stereolithography, but it uses a laser. It uses mirror and laser to basically trace out the design that you want. There's also DLP, which basically uses like a little tiny projector to project the shape of the image that you want for each layer. And then there's the most common type nowadays for consumer printers, which is an LCD screen. It's a monochrome, which basically just means that it lets some variable amount of light through each pixel, and that works. It cures a little bit by shining the light. It lifts up, lets the resin basically fill back in that space, and then does a cure again, and it sort of just keeps doing that to lift the print out of the vat. Yeah. For the slicing software, unfortunately for resin printers, it's much more restricted. There's generally, like, most of the hardware for consumer resin printers is made by Cheetahbox, and it's mostly closed source. And pretty much every consumer one has to use this. There's a slightly alternative software, Lychee. It's pretty much the same as Cheetahbox. And then for basically any other resin printers, it's just going to be whatever software is proprietary to that specific printer. And then, yeah, this is some screenshots this is the Cheetahbox software. It has a similar, you get a preview of what your model looks like. Here I have one print without the supports and then another print with the supports. You tend to need a lot more supports with the resin prints, just because you tend to be printing things with a lot more finer details. And it's kind of, usually if you're printing things, you don't want to print them directly on the build plate. It can cause weird things. So you pretty much always print everything on supports with resin to get kind of the best results. And then, yeah, again, we have a little slice preview. You can drag this little bar on the right here up and down to, like, again, navigate through what each layer of the print will look like. Again, I pretty much only do this if I'm wanting to look for what are called islands, which is basically a spot that's going to get printed with no supports. Because what happens is if there's no support, it just sits on that vat film because it doesn't have anything to pull it off of the film each time the layers go up. Yeah. For operating costs, they're relatively similar to FDM printing, except for the, like, PPE and, like, wash and cure post-processing stuff that you have to do. The resin prints themselves can't really be handled by hand until they've been processed, due to the fact that the resin is a skin sensitizer. Lots of people do it, and they don't take, like, the proper precautions, and you could be fine forever doing it, and you could suddenly start to like, develop allergic reactions and get rashes and things like that. So it's just better to be on the safe side. The actual, like, printing process doesn't quite fully cure the print as well. So the combination of it coming out of the vat and being covered in that liquid, and then the print itself not fully being cured during the printing process, usually it takes several minutes to finish the curing process. And so if you had to do that for every single layer of the prints would take astronomically long. It would be like 40 hours to print just, like, a little mini. Yeah, so usually the build volume is much smaller for the resin prints, or resin printers have much smaller build volume. The resin doesn't go quite as far as with FDM. Yeah, the little knob that's on the keyboard, wherever that went, I can print for like about 1 kilogram of resin. You could print roughly 100 of those knobs, versus the amount that you get out of, like, being able to print the keyboards. Yeah, they're printed from resin. Yeah. Yes, so that's basically the huge advantage. So pros and cons. Yeah, this is a picture of my printer, and you can kind of see how, like, shiny everything is, and then this is, yeah, the resin vat and a fresh print. One of the advantages is you get extremely, extremely high detail. It's basically just dependent on the pixel size of the screen that you have. After about, like, 25-ish micron pixel size, the human eye can't really tell the difference. So hitting that like 25 to 35 micron point gets you like indistinguishable prints where you can't really see the lines. And there's some level of anti-aliasing that you can do, which basically just sort of blurs a little bit of the edges to help hide some of that, like the pixel, instead of having like really square lines. The prints tend to have much more uniform surface finish. So if you kind of compare that to the FDM print, you can see the layer lines a lot more on the FDM versus the resin has nice, just uniform surface. Prints. You can, so this is actually, this picture here was a clear resin that I did add some pigment to. I've had mixed results doing pigments added to resins. They generally, you can buy a couple different colors, but the variety is significantly lower. It has to be a uniform color, yeah. There's no way to have like, I mean, technically you could like pour in a different color like as it prints, but you're not going to get, it's just going to kind of give you like a gradient over time, as opposed to being like nice. Like that printer out there can be like, I want this color for this specific part of the print. Yeah, the prints tend to be much more temperature resilient. So due to the fact that like the PLA, its glass transition temperature is like 60 degrees Celsius, which I don't know what that is in Fahrenheit. But if it sits in a hot car, it can deform. So it's low enough that you potentially everyday things might cause it to deform. So resin prints tend to be much more temperature resilient, where I've actually used them as like molds for injection molding, which is like 240 C or above. And it holds up reasonably well. Yeah, and then resin prints tend to be much more easy to calibrate. You're essentially, the only thing you have to calibrate is the layer cure time for each resin. And otherwise there's basically no calibration. Cons, you basically have to wear protective equipment to work with it. You have to do the post-processing, which is basically you take the print off. Usually you need to use something like an isopropyl alcohol to wash the print, and then you need to put it into a station that has UV light curing, and so it just like has a little like spinning disc and lights that finish curing everything at the end. Again, the build volume is usually way smaller than FDM, but you get the super high details. And then you can have like the temperature, so like if you're printing in a garage or an outdoor space or somewhere that has big temperature fluctuations, that temperature fluctuation can actually change what your layer cure time should be. So you can have some interference with your consistency of prints, especially like you might start a print during the day and it runs overnight. You might see like artifacts of that in the print as things kind of just get affected by that temperature change. Yeah, so sorry, say the question again.
Have you used resin printing to make injection?
Yes.
Because yesterday the album broke was in Paris. I don't know if you've ever heard of.
I didn't.
Talking about the high cost of injection molding.
Yes, so injection molding is extremely high. So generally to make an injection mold, you have to do like a more traditional manufacturing method, which can be extremely high, especially if you're looking for super high tolerance parts. Yeah, it's not nearly as robust as like, usually you use something like aluminum or steel for injection molding. And resin won't hold up. You won't be able to get as many like injection shots basically out of a resin.
Can you use this multi-stage therapy? You make a resin mold and then you
Cast it in another.
plaster up,
Yes.
then you make a metal chair. Each stage
You would lose some details. Casting metal is a little bit of a challenge, so I don't know if you'd be able to do that.
but you can transfer from resin to plaster as well.
Yeah, you can transfer to other materials. I have some examples of I actually use this for making silicone molds and then resin cast stuff in those silicone molds over at the little station over there.
The station with the robots in motion? Or?
No, just right over, kind of in the center where like the checkout would have been for the store. We have a 3D printer set up and a bunch of example prints. Yeah. And then the last type of printer I'll talk about is kind of like this is the third of the three mains, the extrusion, resin, and then there's powder based printing. This one is not really available to the consumer. There is technically a Kickstarter for a $3,700 one, which is like the cheapest, like 10 times cheaper than basically like the next up of this. So it's kind of available, but not really. Um, this one uses it has a big heated chamber and like a tub of powder um, that a laser basically just cures. So it's kind of similar to the resin, except for using a powder. There is a little thing called a recoder that basically just pulls powder from another section to like smooth out the top layer. It has a light laser, gets your pattern, it shifts down a little bit, and then brings more powder over that. So it's usually called SLS, selective laser sintering. And then, yeah, the light source can vary a little bit. So there is like primarily SLS, but there's also a few that use like UV resin and other things to put down. So it basically has like the powder and then like a UV resin or some other binder to collect everything, to attach everything together. Um, yeah.
Powder's still a polymer.
Yeah, it's usually, well, it can be kind of anything that melts together. So a lot of times it's nylon. You can have things like aluminum. You can even do things like titanium if you have fancy enough. Yeah, so this is usually how, like, if you get a metal print, this is how they are made. There's some other kinds, but they're not super common, or they're like just specific. Like, I think there's a company called Relativity that 3D prints rockets, but they have their like own proprietary printer that they are developing for printing metal. That, yeah.
Are you talking about pure metal or a mixture of plastic?
It's pure metal.
Pure metal.
Yeah, so the powder is just specifically whatever the metal is.
Extremely high power stuff. It's titanium 3D printing. Magic, yeah.
Yeah. And then for slicing for this one, it's basically whatever the manufacturer of the printer usually makes their slicer, so you just got to use that one. Purchasing costs is mostly absurd. And then again, like just buying like one thing of the powder is going to be several $100s, and usually to get the nice finish on the part, you need a sandblasting cabinet type thing to get all the powder off. You need the PPE for that because you don't really want to breathe in metal powder or like nylon powder. And the prints, when they come out, it's basically just like the whole big tub like raises out, and you have to like archaeological dig your things out of the powder. uh,
Can you make mixtures of metal and some other plastic thing so that the metal doesn't melt, but you get a partially burnt?
I don't know if you can mix materials in powder-based printers. This is the area that I know the least about for 3D printing, just because I haven't really worked in an industrial setting, and that's really where this is only available. Um, you could probably try. The biggest problem is that most of the time for something like a metal, the melting point is so much higher.
No, I was talking about just embedding metal particles in plastic substrate.
Yeah, you can do that. There's actually some examples of that over at the 3D printing station over there.
Not melting,
Um,
just embedding particles.
yeah, I've seen there's metal. You can also do. There's one technology I know of where you basically print with a metal in some kind of binder, and then they put that in like a big furnace or kiln type thing, and they basically bake it down to just the metal left, and all of that binder agent gets essentially evaporated or burnt off. Um, Usually you have like some like 20 to 30% reduction size from the original print to like what you get out of that kiln.
They have an example of the metal re-engine fuel component, but the PSU cubes out of it.
Yeah, so the most common use that I've seen for a lot of the metal printing right now is for like rocket engines and things like that, as it allows you to get extremely complex geometry and internal geometry that you're not able to get any other way. Since, like, if you have, actually, I'll talk about that in a second. um,
Now I was talking about a different application, more like what I have found from looking around is that you get these liquid polymer based glues. You can mix in graphite powder. You can vary the conductivity,
yeah.
not melting the metals, but varying the conductivity or other dielectric properties of some plastic.
Yeah, most FDM filaments can have some kind of additive added into them that allows you to get different material properties. For example, there is some filament over there that has metal particles embedded in it. Those ones aren't necessarily conductive. That company does, so it's Protopasta has that filament that makes that filament. They also make specifically a conductive plastic filament. No, I don't know that you would really. You probably could do something like that. I don't know exactly what all the technology is available for powder style printers. Yeah, pros and cons. Pros, no supports are required, basically because the part is suspended in that powder. It's all the same weight. It doesn't sink into the powder and just stays. So you can get like the little thing where you have the little ball inside of a cage, essentially. That's all just printed together. The texture, since it's a little bit, it's whatever the size of your powder is essentially going to be your like detail definition. A lot of that hides a bit of the layer lines, so it's much more uniform like texture. You can have access to things that are not printable any other way, like metal, great at complex structures, and then it's really easy to just like fill the entire build volume. So with most printers, stacking things on top of each other means that you like have to break them apart and do things like that, which can be a lot more challenging. Whereas with the powder, since everything is just suspended in the powder, you can use the entire build volume with just like filling it with all of the same object. Cons: powder not compatible with lungs. Doesn't go very well. It can require the entire machine needs to be cleaned out between every single print. The remaining powder, since it's inside of that heated chamber, the heated chamber basically just brings it up right below the melting point of the material. So there's some of that material kind of loses its printability. So a lot of that material, if you don't use the whole build volume, a lot of that material is just waste, and you can't really reuse it. It's super duper expensive, usually like tens to hundreds of thousands of dollars for powder machine. You also have to process the prints. They're covered in that powder. You need to make sure to get rid of the powder before you use the prints. The kind of con of being able to use the whole build volume is that you basically have to use the whole build volume, otherwise it's kind of a waste of the material in the printer. And then, yeah, comparison with other manufacturing methods. 3D printing just generally is a lot better for super complex shapes. You can build more structures, have more internal things that, like, when you're working with a CNC, the router bit needs to be able to pass, like, through to whatever it is. So if you don't have, like, a straight line to internal shapes that you want to cut out, it's just going to, like, destroy that outer section that you want to keep. You don't have to, if you have, like, a big variety of parts, and you only print, like, a couple of them, printing's really great because the same machine can make all of the different types of parts. Lots of material options available. And then for CNC, you might get much higher precision. So the one disadvantage of the 3D printers is they're usually a little bit lower precision than something like a CNC. Most of the time, if you have like parts that mate, you want like a 0.3 millimeter tolerance, as opposed to like a CNC, you can be like 0.0001 like tolerance, where it's like very, very close if you have a well-tuned machine. You can get access to things that you can't 3D print, like you can CNC wood and metals and acrylic, various materials. CNC tends to be much more expensive. Injection molding is awesome if you want like 100,000 of a part. Otherwise, the cost to machine those molds, get them finished and ready for injection molding, can be anywhere from like $10,000 to $30,000 per mold, which is a huge upfront investment. If you're not selling hundreds of thousands of parts, it's not really worth it, and that's where 3D printing is great. Yeah, and then casting, I kind of like to think is sort of like a midpoint between 3D printing and injection molding, because you can make your tooling and then you can cast multiple parts out of the same molds. There is a much lower, like generally injection molding, like you said, you can cast hundreds of thousands of parts out of the same mold, whereas with silicone, usually you get like maybe max of 50 parts out of each mold, depending on how well you take care of it. And then to get really nice casting results, you usually need like a pressure pot, something or a vacuum chamber, something to get rid of the air bubbles that might be in the resin from mixing it. Yeah, and then kind of last thing, well, second last thing, 3D printing services. A lot of the like PCB manufacturers now include 3D printing, include 3D printing surfaces. They have metal, nylons, all sorts of different plastics, that kind of thing. So they're great if you just have like a few items that you want, but don't necessarily want to buy a 3D printer and figure out how to use it. It's a decent way to kind of get prototype parts for much cheaper, and then maybe you want to do more full-scale manufacturing later. Again, you can't really print metal at home, but they can usually have the fancy machines that do metal printing. It can be cheaper in some cases than operating your own printer, based on like, how much time you need to work on the printer and that kind of stuff. And the kind of disadvantage is you don't really have any control over how the final part comes out. It's basically just whatever that service provides. And they'll usually have some information about like what tolerances you can expect and how close to your part that you will receive from them. Yeah, where to start? I say start with FDM printing because it's the easiest to deal with. The bamboo printers have been really great. If you just want to print, they just work, basically. They're, great place to start. If you want to tinker with a printer, get something cheaper, like any of the like Ender 3 type printers with the bed slinger thing, and yeah, those are usually great. You can get them for as cheap as like $150. You're going to learn a lot about 3D printing and the 3D printer. It might take a year or two before that printer actually gives you the parts that you want out of it. Yeah, if you need engineering materials like nylons, carbon fiber, infused materials, things like that, you usually want something enclosed. And then, yeah, if you need the details, resin printer is great for details. The one thing to watch out for with resin printers is that they always advertise their like 8K or 12K screen resolution, but an 8K screen at 15 inches is going to have bigger pixel size than that same 8K screen at, say, like a 10-inch screen. So what you want to try and look out for is the pixel size. Basically anything lower than like 35 microns is pretty good. You won't really be able to tell the difference with the human eye after that point. Yeah. And then larger build volumes for resin printers can have more print failures and issues just due to essentially friction forces between the print and the vat film. So like if you're printing a really large surface area thing, it requires more suction essentially to get it apart, and it can have detrimental effects. I usually recommend getting the smallest printer that fits the thing that you want to print. And then, yeah, if you want super fancy materials, you can try your luck with the SLS Kickstarter printer. And then, yeah. Probably, no.
Can you go back a slide?
Yes.
Can you explain why that firmware is useful?
Yes, Clipper. So Clipper is an open source firmware. It gives you access to a web UI for your printer. It has also been the most easy to make changes to. So the other most common one is Marlin. That requires like actually fully compiling the firmware, recompiling editing code, doing the whole compilation process to get the firmware to update. Whereas Clipper just has a nice little like text thing. You basically just edit a text file to basically just say like, I want this feature, or like this setting should be set to this, and you just save it and restart the printer, and it updates. It has compatibility with a lot of nice things, like you can plug in a camera to monitor your prints. Yeah, you get the network printing, so you don't have to take like a USB drive from your computer and plug it into the printer to get that sliced file between the two. You can just send it over the network. And then it's also all local to your network at home. So like it's not, the Bamboo printers have to use their cloud software to do network printing. So you have to like submit it to their cloud and then download. So that's kind of a disadvantage to the Bamboo printers. They claim no, but yeah, they definitely could be keeping copies. There is a big concern. That was a lot of larger companies do have that concern with them, and so there is technically a like LAN mode, but it requires you to walk physically like USB drives between the printer and the thing, because yeah, bigger companies are less keen on having their proprietary files sent through the cloud to somebody. Yeah. Yeah. Any other questions?
The Bamboo, do those, like the ones you have out there, do they typically have, if it's enclosed, is it typically heated, or is the heating module a separate thing?
Enclosed printers do not generally have a heating module in them. You can build your own heating modules. I know that the Bamboo Labs X1E is their like enterprise model. It's like $2,500 and has local network things and other stuff. It's not really worth the cost, but it does have an actively heated chamber. You don't need most materials that you're likely to print with, you don't need an actively heated chamber. It's just having it enclosed helps. Usually the heat from the build plate and the print itself can help like create an ambient temperature that's acceptable. Yeah. I think that's everything, unless anybody has any other questions. You can also come bug me. I'll just be standing over with the 3D printer over there, so bug me for whatever. Yeah. Hopefully that was helpful. A little information dense, but you know.